Hello, everybody. Today we will be solving problem 4 of the 2020 JMO. The problem reads, let ABCD be a convex quadrilateral inscribed in a circle and satisfying DA is less than AB is equal to BC is less than CD. Points E and F are chosen on sides CD and AB such that BE is perpendicular to AC and EF is parallel to BC. Prove that FB equals to FD. Okay, I've drawn out this diagram over here, and I've also added two triangles, triangle CEA in green and triangle BFD in red. And the reason I've added those is because I am going to solve this problem by proving a series of claims, which I've already written out over here. I'm going to claim that triangle CEA is isosceles with CE is equal to AE. I'm going to claim that AFED is cyclic, and I'm going to use those to claim that triangle CEA is similar to triangle BFD. And by this first claim, BFD would also be isosceles with BF equal to FD. Okay, so we're going to start with this pink claim over here. I can call it lemma 1 if I want. And that is that CEA is isosceles. And that's not hard to prove because we already know AB is equal to BC, right? And so I have labeled this point over here M, the intersection of BE and AC. And note that BM is perpendicular to AC and also that EM is perpendicular to AC. Right? Then what would we have? We would have, since this angle's right, angle BMC equals to angle BMA equals 90 degrees. We have BC equals to BA. So we'd have BC squared minus BM squared equals MC squared and BA squared. Let me draw this B out a bit better. BA squared minus BM squared equals MA squared. But since BC equals BA, we have MA equals MC, right? And it follows that M is the midpoint of AC. And similarly, since this angle EMC and this angle EMA are both right, we have MA squared plus ME squared equals CE squared. And no, sorry, excuse me, this is a C. MC squared plus ME squared is CE squared. MA squared plus ME squared equals AE squared by Pythagorean theorem again. So CE is equal to AE. And that proves this claim up here. Triangle CEA is isosceles with CE is equal to AE. Right? So I can get rid of all of this work over here and over here. And I am going to put a check mark over here because we've proven it. Okay, my next claim is that going to be quadrilateral AFED is cyclic. So this quadrilateral over here. This is also not hard to prove. The answer is the reason is because this angle over here is going to be equal to this angle over here. Angle DCB is going to be equal to angle DEF because EF is parallel to CB, so we would have a transversal, right? But we are given from cyclic quadrilateral ABCD that angle DAB plus angle DCB is 180. Right? But angle DCB is equal to angle DEF and angle DAB, this one over here, we can also write as angle DAF, right? because AF and B are collinear, we have angle DAF plus angle DEF is 180 as well. And that is enough to prove that since opposite angles of this quadrilateral AFED sum up to 180, AFED is cyclic. So that proves that claim. I'm going to erase this again. And now our final claim is that triangle CEA is similar to triangle BFD. And that should be pretty easy as well. And the reason is because we have angle DEA equal to angle DFA from this cyclic quadrilateral we have just proved is cyclic, right? So angle DEA is equal to angle DFA because they both subtend this arc AD of this cyclic quadrilateral, right? So the supplement of this angle is equal to the supplement of this angle. So, right, so 180 minus the first one is equal to 180 minus the second one. Right? But 180 minus angle DEA is equal to angle AEC. So angle CEA. And then this second angle, 180 minus angle DFA, is going to be equal to this angle, angle BFD. Okay, so that's one angle done. So I will draw this angles using squiggly marks. This one as well. Okay, then we just need to show one more angle of the two triangles are equal to each other, and that's easy because this angle over here and this angle over here both subtend this arc AD of this circle. So I can write that out as angle DCA equals angle DBA. Right? Or we could write this as angle ECA is equal to angle FBD. And now we have these two angle equalities. And since they're equal, since these two angles are equal and these two angles are equal, we have this similarity is actually true. However, if triangle CEA and triangle BFD are similar and triangle CEA is isosceles, triangle BFD must be isosceles as well. So we can write this as CEA isosceles so BFD isosceles as well. And in particular, since C equals AE, then FB equals FD. And we are done. Thanks for watching, and I will see you next time.